Hey everyone, welcome to the semicolon. In this tutorial, we're going to implement a toy recurrent neural network which will predict the next digit when you give it a sequence of consecutive digits. This video is about implementing recurrent neural networks. If you want to understand how recurrent neural networks and LSTM work, watch the tutorial on working of RNNs and LSTMs first, and then come back here to look at the implementation. This channel also has lots of tutorials on machine learning and data analytics, so you may want to have a look at them as well. In this tutorial, we'll be implementing an LSTM, we'll be visualizing the results, and we'll also visualize the convergence of our LSTM. We'll do it for one layer first and then add another layer on top of it, and then we'll learn how to train a RNN or LSTM with variable sized inputs. We'll be implementing a LSTM here, but the process is pretty much the same for the simple RNN or the gated recurrent units or the GRUs. So let's get started with the implementation. We want our model to predict the next digit. So when you give 5, 6, 7, 8, 9 as input, your model would give 10 as the output. Pretty simple example with no practical use, but great for learning. And in future, we'll be implementing RNNs with texts and images, and maybe even music. So let's first understand the basics here. To implement, we'll be importing all the necessary libraries first, sequential from Keras models, dense and LSTM from Keras layers, train test split from scikit-learn model selection, NumPy and matplotlib as usual. And before we start implementing LSTM, we'll have to prepare our data in the format we want. So this code here generates 100 vectors of 5 consecutive digits into the variable data, and the target will store the 6th consecutive digits. Now the data vector has consecutive digits like 0, 1, 2, 3, 4. And note that these digits 0, 1, 2, 3, 4 are vectors of size 1 cross 1. And when dealing with other use cases like text, images and all, these vector sizes may change. And the target here has the next digit, which is 5. So let's convert all of these to NumPy arrays and then check the shape. And we'll be using these shapes as parameters when we'll be implementing LSTMs. So then we split the data into test and train, and we are done with the creation of data. So here comes the interesting part, which is implementing LSTM and watching it learn. So we start with model equal to sequential and then add LSTM layers. So while adding LSTM layers, we would need to specify some parameters. So the first parameter is the output size, which is 1. We want 1 output. And the batch input shape describes the input shape of our data. And the format is the number of inputs, length of input sequences, and length of each vector. Now if you do not know the number of inputs in your data, you can replace the value with none. And 5 here represents the length of our input sequence, because we'll be giving it 5 digits. And 1 represents the length of each vector. So our each vector is 1 cross 1. Now return sequences true would return output after every node, and setting it to false would return just one output at the last node. And in our application, we would need it to be false because we just need one output. We then compile the model with the loss function mean absolute error and Adam optimizer, and we would like to see those loss and accuracy values. So we specify matrix as accuracy, and model.summary gives us the summary of model where we can verify the shape and the number of parameters. So now we fit the model on training data and give the test data for metrics. Model.fit returns the history of training, which can help us in visualizing loss. So now we can fit the model on training data and give test data for metrics. Model.fit returns the history of training, which will help us in visualizing loss. Now we run it and epochs is EPOCHS. And so we run it again, and the error is because we forgot setting return sequences to false. So while our target has one single digit, the model was expecting 5 different digits. So setting it to false will solve the error, and then running it again, the loss seems to be decreasing, but the number of epochs seem to be very less. Anyway, let's plot the output and loss, which will help us in understanding the reason behind the poor results. So model.predict give us the results, and let us compare the results with expected test results. So red color for results given by our model, green color for the expected ones. And oh, the model is unable to learn anything, and all the results are 0. So let us look at our loss plot. So the loss seems to be decreasing. Maybe increasing the epochs will do. So let's try and repeat again. And no luck. The loss decreased further though, but no luck. The results are as horrible as they were. So there's one thing we did not do to our data, which is normalization. It makes, if we do not normalize the data, it makes the gradient very high, and it makes it difficult for our model to learn anything. So let's normalize by dividing by 100 and try to retrain the model. Now this time the plot is much better, which means our model was in the process of learning. Now looking at the loss plots, we can say that our model has not yet converged. So to get the maximum out of our training, we need to stop the process when the loss is almost stagnant. But here the loss is still decreasing, and we stopped it prematurely. So we need more epochs. So let's make it 400 this time and train the model. And then we visualize the results. And this time they almost fit perfectly. And even the loss has gone down by a lot and is almost stagnant, but still decreasing. So let me add one more layer to the model to understand the implementation of multi-layer RNN or LSTM. So this time I make the return sequences true because we want output after every node. And these outputs will be passed to next layer. And we want one output from our next layer. So we make the return sequences false there. Now compile the model, and model.summary shows 24 parameters. Now if you want to understand what each parameter means, then the video which explains LSTM and RNN explains each parameter, and it will be nice to watch that. Now training this model, while this trains, have a look at the graphs so that we can compare the difference. We can execute the same code. And the results seem little better, and our model converged lot before 400 epochs. So this is how we implement any RNN or LSTM. But then RNNs or LSTMs give the most value when you have the liberty to throw variable sized inputs at them. There are two simple solutions to it. The first one is padding zeros to the input so that you can make the size of all inputs same. Say one sequence of your input is 3 and other sequence is 4, you can add a 0 to the sequence of size 3 and it will become size 4, and then you can train your model. But many don't feel good about this solution. So another solution is to make the sequence length none and the batch size 1. Or one more thing which you can do is group the data by same sized inputs and then train in the groups. So but you'll have to change this parameter to none. So for example, we will train the same model with input sequence of 6 and input sequence of 7 without compiling it again, because compiling it again will reset the model. So this got trained with 6 input sequences, and now without compiling the model again, we change the data and run it on 7 input sequences, and the model is being trained and the output is pretty good too. So this is how we can train LSTM with multiple layers and multiple input dimensions. So we'll be looking at more examples with RNNs and other deep learning models in future. Thank you.